Okay, so now we move on to the unit circle. Uh, so the unit circle, you have to know your unit circle. You have to know this for it's gonna make it a lot easier for a lot of advanced subjects on physics and calculus, especially the early ones. And so the unit circle, all it is a representation of a circle basically, and the angles that compose a circle. So um, this first line here is always going to be 0 degrees. Yeah, this is going to be 0 degrees here because it's 0 degrees. So, and what's important to know is that it's always going to be relative to the angle to the horizontal. So the angle here is 0 degrees. This is going to be a 90-degree angle, so it's going to be 90. This is going to be 180 degrees, so this is going to be 180. And this is going to be 270 degrees. And that's complete the circle, and it's 360. So that's basically what the circle is. It's the degrees, representation of degrees of a circle, and the angles. And what we do with the unit circle, especially we memorize those ratios and what they represent, because it's always gonna be, especially in trigonometry. And we'll look at graphs after, but it's very if you want to find the value of an angle or the ratio at which an angle is, the unit circle is going to be very useful for that, and especially in terms of graphs and finding what the sine of something is, or the cosine of something is, or the inverse cosine of something is. So the first thing we gotta learn are the unit circles. Often you have to know it in radians, because it's often gonna come up like that. So I'll show the radians in a minute. Okay, so these are the ratios. So 0 degrees are going to be 0 pi, or 2 pi. That's 360 is 2 pi. So that's just basically one whole revolution of the circle is going to be 2 pi. Now 90 degrees is going to be pi over 2. And 180 degrees is going to be pi. So pi is half a circle. And then 270 is going to be 3 pi over 2. Now, it is possible to do this in terms of negative. So this, so if we just take the negative out of everything, this could be also a negative pi over 2, because it's going to be like negative, so instead of going here, it's going to be here, so negative pi over 2. It's the same as 90 degrees, so it's negative 90 degrees, it's just plus 90 degrees here. Negative pi, it's the same, it's not going to change. Negative 3 pi over 2, it's going to be here. And then it doesn't change for negative 2 pi, but just know that it could be negative, and don't get confused just by that. Just kind of do it in reverse, I would say. So it is important to know these ratios and what to do with them, so we can do the next step, which is what we want to do, which we want to help solve trigonometric functions, trigonometric ratios, what the arc of something is, what the tangent is, what the sine is. So that's what we're going to do next. Okay, so now with the unit circle, which we created the 3 special triangles. So the blue one over here, the black one over here, and just remove this, the red one over here. So this is basically we created special triangles because of the angle of each of these vectors. So basically we have 30 degrees here. Just do 30. 45 degrees on the middle one, 45, and 60 on the blue one, and those just basically represent the angles and what we can do with the unit circle. So in terms of radians, you do need to know this. In terms of radians, 60 degrees, it's going to be pi over 3, and this makes sense because if this is pi right here, right, then, and that's 180. 180 divided by 3 is 60. That's going to be pi over 3. The 30-degree angle, it's going to be pi over 6 because of the same thing. It's going to be pi over 6. And the 45-degree angle is going to be, what's 45? Times 2 is 90. Times 4 is 180. So pi over 4. And it's important to know this. What the 45 degrees pi over 4, 60 degrees pi over 3, and 30 degrees pi over 6, because this allows us to use ratios. Now we know what's the opposite of 30 degrees. It's going to be the opposite of pi over 6 as well. So it's going to be it's going to be 1. The opposite of 60, it's going to be square root of 3. And the opposite of 45, it's going to be 1. And we'll just leave that for now as it is, and we can come back later to one of the problems. So now we need to know what these angles represent in terms of the whole unit circle, so around here. Now keep in mind, we know this is 0 pi, right? And this is pi. So if we want to find out the 60-degree angle here on this quadrant, or the 30-degree angle here on this quadrant, or the 30-degree angle here on this quadrant, we just need to know what pi and 0 pi basically. So if we take the same angle, pi over 6, 3 degrees on this quadrant, so this is 30 degrees, right? This is pi. So in terms of in terms of 1 pi, in terms of over 6, basically it's going to be 6 pi over 6, right? Because this cancels out and that's pi. But basically what we're doing now, it's representing pi in terms of how many 30-degree angles fits in pi, basically. So it's 1 over here, then it's going to be 2, 3, 4, 5, and 6. So this is the last 30-degree angle. So this is going to be 5 pi over 6, because that's the last one. You just subtract 1 from whatever ratio represents pi. So in terms of 30 degrees, because it's pi over 6, it fits in 30 degrees. It fits in 180 degrees. It fits in pi 6 times. So it's going to be 6 pi over 6 when it's 180 degrees. And we just subtract 1, and so 30 degrees over here on the second quadrant. So this is 1, this is 2. It's going to be 5 pi over 6. Now the same thing goes for pi over 4 and pi over 3. So in terms of, let's do it with pi over 4. So this is going to be 4 pi over 4. And so this is going to be 4 pi over 4. And because it's the last pi over 4 that fits, because it's pi over 4, then we just subtract 1, and this angle, it's going to be, if it's 45 degrees, this is going to be 3 pi over 4. Just subtract 1 from the ratio of pi, so in terms of 45-degree angles, in terms of pi over 4, it fits 4 times. So for pi over 4, it's the same as pi. So you subtract 1, 3 pi over 4, and the same goes for pi over 3. So 3 pi over 3 is the same as pi. So you just subtract 1, it's 2 pi over 3, because that's basically just the last angle. So it's going to be 1 pi over 3, it's going to be around here, 2 pi over 3, and that's going to complete the angle at the second quadrant. Now it's very similar on the third quadrant. You just need to take into account the same reference of pi. So I'll just write what in terms of pi over 3 angles terms. Okay. So it's basically the same thing here. If we create a 30-degree angle, a pi over 3 radian angle right here, it's going to be 1 more than 6 pi over 6. So we create 1 pi over 6 angle. It's going to be 1 more than 6 pi over 6. So this is going to be 7 pi over 6. You just keep at 1 or subtract 1 depending on your. So that's the third quadrant. So just add 1. So 5 pi over 6, 6 pi over 6, 7 pi over 6. 6 pi over 6 is the same as pi. So in the second quadrant, where you took 1 less angle from 6 pi over 6, it's going to be 5 pi over 6. And on the third quadrant, where it's 1 more pi over 6 angle, it's going to be 7 pi over 6. And that's basically how it works for everything. So in terms of 4 pi over 4, it's going to be 5 pi over 4. And in terms of 3 pi over 3, it's going to be 4 pi over 3. No, let's do a similar thing on the fourth quadrant. And IV, it's just the fourth quadrant. So it's similar here. It is 5. Let's do a pi over 3. We'll just change a little bit of pi over 3 angle. So let's do a pi over 3 angle. We know that's 60 degrees. Now we use what now remember that this is not only 3 pi, it's 2 pi, because 2 pi is 360 degrees, so that's 1 whole revolution. So this basically, in terms of 2 pi, this is basically 6 pi over 3, because if 6 divided by 3, it's going to be 2, so that's going to be 2 pi. So with the same that we did here, we subtract 1 from 6 pi over 3, because this is 160-degree angle less than 2 pi, so that's going to be 5 pi over 3. Sorry, 5 pi over 3, yeah. So it's the same thing for a 45-degree angle on the fourth quadrant. In terms of 2 pi, it's going to be 8 pi over 4, because 8 divided by 4 is 2 pi. So we subtract 1, and it's going to be 7 pi over 4. And it's the same thing for pi over 6. Now, if you want to do that conversion in terms of 2 pi, you just have to do kind of a ratio, let's say like that. So it's so if you want to learn how to why that works, if you want to do that conversion, we basically take 2 pi, which is 1 revolution, and then we divide it by either pi or by 3 or 4 or 6, which is like in terms of how the angles are going to be divided. So let's do 6. Okay, now we know that to whatever we do to the bottom, we have to do to the top, so we have to multiply 6 as well over here, and that's going to equal 12 pi over 6, and that's where you get your value of 1 revolution in terms of 30-degree angles in terms of pi over 6, basically. So we just want to subtract 1 if we're here, and we want to find the angle of, if it's 30 degrees and we want to find the angle here, just subtract 1, and it's going to be 11 pi over 6. So that's basically how your angles are laid out in the unit circle. And now we're going to look at how it works in terms of solving trig equations and ratios.